So point laser means one scanner will emit 640 points over the road surface. And similarly, second RT scanner will also emit 640 points on the surface. And with the help of these points, a profile will be generated, and automatically it will give the RUT depth. So this is the RUT scan profile view. So these are the road geometric features which we get from this network survey vehicle: gradient, rise and fall, cross slope, and horizontal curvature. This is the gypsy track. So these are the some specifications of this. So gypsy track it can work at a speed of 0 to 120 kilometers per hour. So I was talking that the minimum speed for this NSV is 30 kilometers per hour. So basically, below 30 kilometers per hour speed, the laser sensors will stop working only. So all other components will work, like camera will work, pavement images will work, right? But on two parameters will stop working below the speed of 30 kilometers per hour. That is your laser sensors, laser profilers. And so we are not able to get the roughness, and we are not able to get the texture if we are moving at a speed less than 30 kilometers per hour. So you know the surface distresses. So this is cracking, alligator cracking, or this is a longitudinal crack, this is a transverse crack, and this is patching, edge break, pothole, etc. So all these distresses which we can identify using the cameras which are installed at the backside. So this is the modern technology which we are using. So obviously all these things we can determine manually, right? But if we need to cover the huge road network like we are doing in currently in Odisha state, so we need these modern technologies only, because without that we are not able to cover this huge road network. So if you see, if we do the manual method, the survey length we can cover is only 20 kilometers per day. And however, if we are using this NSV, so we can cover up to 200 kilometers per day. And in this case, just you have to sit inside the vehicle, so safety is also there, right? And data you are collecting is at traffic speed, right? So many benefits are there of using this network survey vehicle. So these are the cameras which are installed at the backside of the. You see that one frame will capture the area as 3.5 meter is the width of the lane. So yes, if you are there, if you are running this vehicle, suppose 4 lanes are there, so one run will cover only one lane at a time. So if 4 lanes are there, so you have to run this vehicle 4 times. So this is the frame or image which is captured by these 2 cameras. So the image width will be 3.5 meter, and this length will be 2 meter. So you see, this is the image which is captured using this camera only. So you see the resolution of this image, and this image is being captured when the vehicle is moving at a speed of 80 kilometers per hour. So you can imagine that when this vehicle is moving at a speed of 80 kilometers per hour, so what is the resolution of this image which is captured using this camera? This is the front camera which I already discussed. This is one of the screenshot of the camera. You see, I was talking that when you transfer that video in your laptop and you are analyzing the data, so you are just moving the cursor from this point to this point, and automatically it is showing here that the width of this lane is 3.542 meters. So very accurate measurement is there. This is the GPS system which is installed at the top, which is very useful to locate any kind of distress. And obviously all the data is collected with distance. So one DMI is also there, which is installed at one of the wheel. And this is the operator's console. So you see, this is the front portion of the vehicle. One side the driver seat is there, and one side the operator seat is there. So this system is installed at the front desk, and with the help of this keyboard, just we have to give the commands, and all the things will be shown here. That if suppose if any one of the component is not working, so it will be shown here in this screen only. This is the close-up view of data acquisition system. Now this is another equipment. This is another equipment. So this is known as falling weight deflectometer. So basically, this falling weight deflectometer is used to analyze the structural evaluation of the pavements, right? And that network survey vehicle is used to analyze the functional evaluation of the pavement. So, like for example, we are given this huge road network in Odisha PWD state, Odisha state, that is 23,000 kilometers. So what we have done is we have completed the survey using network survey vehicle for all the 23,000 kilometers of the road network, right? Now, after analyzing that 23,000 kilometers of road network using that NSV, we got to know that which of the roads are in excellent condition, which are in the good condition, which are in the poor condition, which are in the fail condition, likewise. So to judge this thing, that which road is in the excellent condition, which is in the poor condition, we go by the concept of PCI, right? So PCI is pavement condition index. So based on the data which we have collected, like distress data and roughness. So these are the two important data parameters which we collect from NSV. Distress data, like what is the percentage of cracking, what is the percentage of patching, what is the number of potholes, and what is the rutting present. So all these distress data we have collected, and the roughness data we have also collected. And based on the code which is given as IRC 82. So equations are given, and we just input that data in those equations, and we determine the PCI value for each road, right? So if the road, that PCI value is, so the scale is between, for that PCI value is between 0 to 100. So if the 100 means excellent condition of the road and 0 means fail condition of the road. So now what we have done, we have eliminated those roads which are in the excellent condition. So the roads whose PCI score is more than 80, we have eliminated those roads. Now, whatever roads which are there whose PCI score is less than 80 or even less than 60, we will decide. So we are conducting this structural evaluation of the pavement, right? So many of you are aware, we use BBD technique, Benkelman beam technique, right? So it is kind of similar thing, but in case of BBD, we apply a static load. However, in this falling weight deflectometer, we apply a dynamic load. So again, this is the falling weight deflectometer, which is procured by CRRI, and it is used to measure the structural evaluation of the pavement. So in this, we apply a load over the pavement surface, and the deflections are measured using the sensors or geophones. So basically, if I talk about the difference between Benkelman beam and this falling weight deflectometer, so what is the major difference? So the main difference is in BBD, we apply the static loading, right? So there we apply, we use a truck, a loaded truck is there, and the truck moves through some distance, and we measure the rebound deflection, right? And also that code was developed in 90s, and it was IRC 81. So that code was developed when nowadays we are having bituminous layers like bituminous concrete, dense bituminous macadam. So dense bituminous mixes we are using nowadays. But the code of BBD, which was developed earlier, it was developed when there were no dense bituminous layers like bituminous macadam was there and Timis carpet was there. So that is why nowadays we are shifting towards this falling weight deflectometer. So here what happens is, this is the inside view of this falling weight deflectometer. So if you open this box, so you will see like this. So if you see here, a circular loading plate is there, right? And circular loading plate, so it will rest over the pavement surface. And if you see this spring, where these springs are there, so geophones are connected. Geophone is basically used to measure the deflection over the from the pavement surface. So we apply load over the pavement surface. So normally in case of roads, we apply a standard load of 40 kilonewton. So when this load is impacted over the pavement surface, so deflection will be there, and these deflection will be measured using these geophones, right? So with the help of these geophones, when you get these deflections, so these deflections will be used in KGP backed software, which is as per IRC 115 guidelines. And with the help of those software, with the help of that software, you are able to find out what is the overlay required over the pavement surface. Also, same thing we determine in BBD. But in BBD, you are not able to determine the various properties of the component layers of the pavement, like subgrade, granular layer, and bituminous layer. So we need to determine the modulus of these layers. So in case of BBD, you are not able to determine the modulus of these three layers. But in case of falling weight deflectometer, you are able to determine the thickness this modulus of these component layers. So it is non-destructive in nature and fully automatic system, which is used for determining the structural capacity of in-service pavements, and it simulates the heavy moving wheel load. See, it produces load effect ranging from 24 to 240 kilonewton. So this falling weight deflectometer, so which we are having, this is basically our heavy weight deflectometer. So heavy weight deflectometer is nothing but the load capacity is up to 240 kilonewton or sometimes 300 kilonewton. So many SWDs are coming nowadays. So the load capacity is up to 300 kilonewton. So normally on roads we require 40 kilonewton load. So why we are having this heavy weight deflectometer? Because this deflectometer is also used over the airfield pavements like runways, taxiways, and aprons. So what is the use there? First use is obvious, that we need to determine the overlay required over the runway, right? Now, another use in case of airfield pavement is we need to determine the ACN or PCN values. So PCN is basically your pavement classification number. So that pavement classification number we can determine using this heavy weight deflectometer. Now from November 2024 onwards, this PCN concept is changing, and for all the airports or all the airports, we need to take PCR value. PCR is your pavement classification rating. So this is changing from November 2024, and CRRI is working in that direction. And again, we will be taking Airport Authority of India in this, and then we will be converting all the PCN values to a PCR. So the impulse load is created by dropping a variable weight. So weight can be varied. So how weight can be varied? We can drop the weight from different heights. So in that case, we can vary the weight. Also, the number of plates are also there, which we can increase or decrease. So on the basis of number of plates and by changing the height, we can vary the load. So now, what is the advantage of this falling weight deflectometer? So the load pulse generated by the impact of falling weight causes a deflection that is closely simulating the normal traffic. So basically, what we are doing in this falling weight deflectometer, we are simulating the actual movement of the traffic. So this is simulating a truck which is moving at a speed of 60 kilometers per hour. So if you imagine that you are standing over a particular point over the pavement and a truck is moving at a speed of 60 kilometers per hour. So what is the load which is applied to a particular point over the pavement when the truck is moving at a speed of 60 kilometers per hour? So you can imagine what is the duration it requires. So if a truck is moving at a speed of 60 kilometers per hour, so imagine what is the time required to apply that load over one point over the pavement surface. So it is in terms of less than a second, in terms of milliseconds. So it is approximately between 15 to 30 milliseconds. So that kind of thing, it is being simulated in this falling weight deflectometer. So loading conditions are also simulated, the magnitude and time of loading. Major deflections used for back calculation of pavement layer properties. Now, what are the basic output which we get? So basic output from falling weight deflectometer we get is air temperature, pavement temperature. So all these things are also measured by sensors. So like in BBD, we need to dig a hole and put some glycerol and thermometer inside that hole to measure the temperature of the pavement. But in this case, sensors are there which will automatically record the air temperature as well as the pavement temperature, which is very important to for the analysis part. So this is the basic output. So if you see here, this is the impact load, and this D naught is basically we determine the deflection at the center of the load, and these are the other geophones or deflections which we measure and which are placed away from the center of the load. So this D6 is placed at the farthest point from the center of the load. So you see, obviously, the deflection will decrease when the sensor or geophone is placed at a far point from the center of the load. Now, another important technology or equipment is GPR technology, that is ground penetrating radar. So while we do this falling weight deflectometer survey, so after conducting this falling weight deflectometer survey, we need to analyze that data. And to analyze that data, we used KGP-backed software. And in that software, we need to input the thickness of various component layers of the pavement, like bituminous layer, what is the thickness of bituminous layer, what is the thickness of granular layer, like this. So in that case, either we have to open the pavement, like we have to cut a pit in the pavement, and from there we can determine the thickness, or so that case it will be destructive method. So if we go with non-destructive method, so we use this GPR methodology. So here with the help of this GPR, normally GPR is used to determine the what is present inside the pavement, like under utility, some pipeline is going on. So like these things are required, this GPR is required to predict that where it is present, this pipeline is present. But now research is going on, and we are able to determine the thickness of various component layers of the pavement. So GPR is a non-destructive geophysical method that uses radar pulses to image the subsurface, and here it sends the electromagnetic waves into the pavement and records the reflected signals from different layers. The application in pavements, so GPR is widely used to determine the thickness of various pavement layers, and here it works, so it transmits the signals and it receives the signal, and it works on the principle of dielectric medium. So so with the help of the change in the dielectric medium, so obviously the bituminous layer have some different dielectric constant, and the granular layer will be having some different dielectric constant. So when there is a change in the dielectric constant, so we need to depict the change, and with the help of that signature, we are able to determine the thickness. So you see the dielectric constant. So air is having the dielectric constant of 1, and water, fresh water, is having the dielectric constant of 80. So this is the maximum dielectric constant, and air is having the minimum dielectric constant. So all the other materials, whatever present, so will have a dielectric constant value in between 1 and 80, right? So with the help of those, so like asphalt is having in the range of dielectric constant is between 3 to 5, concrete is 4 to 8, dry sand 3 to 6, wet sand 20 to 30. So because the sand is wet, and you see for the water, the dielectric constant is 80. So you see for dry sand, the dielectric constant is 3 to 6. But when water is there with the sand, wet sand, so dielectric constant jumps to 20 to 30. So with the help of these things, we are able to determine the thickness. So this is one of the survey which we have conducted near the India Gate. So because here this is very VIP area, so we were not allowed, CRRI was not allowed to open the cut open the pavement or to cut the to cut the pit. So that is why we have used this GPR technology to determine the thickness of the pavement. So here this is one of the typical view of GPR output at Rajpath. So the top 3 layers here you see the presented by red, yellow, and green represents the bituminous layer. The next 2 layers which is represented a pink and violet color represent the subbase and base layer, and remaining layers represent the subgrade. So in this way we conduct this survey. So currently today also I am present in Odisha only because I have came here to conduct the falling weight deflectometer survey. Already this network survey, vehicle survey is completed, and now we have started this falling weight deflectometer survey. So thank you. And if any questions, then you will please ask.
Thank you, Aakash sir.
Yes, sir.
For your wonderful presentation. Anyone from the audience, they may ask questions. Aakash sir, I have some few questions.
Yes, sir.
First of all, since you are in this field, in the research field of CRRI, just I want to assure that how you assure the quality of the work that is being, or the results output that you are getting.
Yeah. So basically, sir, whenever we conduct the test, so we do the calibration. So NSV or whatever, falling weight deflectometer or network survey vehicle. So all the equipments we calibrate. So before testing, we calibrate, and we have calibration. The validity of that calibration is for 1 year. And also some basic equipments are also there, which we use to collect this data manually. So like if I talk about the roughness parameter. So the basic equipment is dipstick profiler. So it is a handheld equipment. So with the help of that equipment, we can measure the roughness, suppose 100 meter. So also we are having the data for that NSV results. So from there we compare the data, and we are able to check that whether our equipment is giving right data or not.
Okay. And for different types of experiments, number of samples you take, for an example, for core cutter method, how many samples you take usually?
Like core cutting, sir. So basically it depends on the extent of the project. So suppose currently one of the project we are working for Indore. So there we have given 100-kilometer road. So for 100-kilometer road, if we want to cut the pit, so we have taken the frequency 20 kilometers. So because we cannot cut the pit throughout the section, so every 20 kilometer or every 10 kilometer we are cutting one pit. And for cores, for 1 kilometer we take 2 cores. If the section is like 100 kilometer of road is given to us in Indore, so for that case. But in this case, like this for Odisha, 23,000 kilometer of road network is there. So the objective here is something different. So the objective is like we need to prioritize this road network that which needs to be maintained first, and obviously this can be done. So some budget is allocated to this Odisha PWD, and so we are doing the constraint budgeting of the roads with the help of SDM4 software. So that SDM is basically Highway Development and Maintenance Software. So with the help of that software, we need to input the data in that software, which we get from this NSV falling weight deflectometer, and then with the help of that software, we are able to prioritize the roads on the basis of the budget.
Okay. So thank you, sir, for your wonderful presentation.
Thank you, sir.
Thank you, sir.
Good evening, sir.
Shall we start?
Yeah, we can start. Sure.
Okay. So good evening to all of you. Our next kilos lecture series will be given by Dr. Aakash Kumar. He is currently working as an assistant professor in the Geotechnical Division, Department of Civil Engineering, IIT Palakkad. So I welcome you to this conference, sir. Before joining IIT Palakkad, he worked as an assistant professor in the Department of Civil Engineering, Sardar Vallabhbhai National Institute of Technology, Surat. His research areas include geothermal energy, rock mechanics, underground structure, blast impact loading, and petroleum-related rock mechanics. He did BTech in Civil Engineering from NIT Trichy, MTech in rock mechanics and underground structures from IIT Delhi, and PhD in rock mechanics from IIT Delhi. He received IGS HICO Best Paper Award on Rock Mechanics at Indian Geotechnical Conference in 2015. He reviewed research articles from several journals, including Journal of Rock Mechanics and Geotechnical Engineering, Structures, Geotechnical and Geological Engineering, Geostatistics International, Geomechanics Engineering, Journal of Geological Society of India, SN Applied Sciences, Scientific Reports, Nature, and etc. So I welcome you, sir, on this conference, and I guess that our participants will get the knowledge from you of your experience. So let us I give this dice to you, sir, to continue.
Yeah. Thank you, Saurav. So I'll just share my presentation. So I hope this presentation is visible to all of you, right?
Yes, sir. Yes, sir. Is visible.
Okay. Yeah. So today I'm going to discuss about the particular topic that is rock engineering for geoenergy. Till now, you might may not be aware about how this rock engineering is applicable in the field of energy sector. So those things I will try to cover here, and also as your conference title suggests, that sustainability, that also I tried to include in this particular keynote lecture. So as we all know, energy is an important thing right development, even our day-to-day life, like household uses and all. Energy is everywhere. That each country in present scenario want to become developed, so want to achieve some sort of self-reliant in the terms of resources. For the energy are coal and petroleum. If you look into the coal, that is mostly 70%. Our the geothermal production, not geothermal, the thermal production is from the coal, and it's about 70%. So petroleum is equally important in that aspect. Development suggests that we are all these sectors. But if you look into the utilization or energy generation with respect to the non-renewable and renewable energy resources, there is a huge gap is there. And all the solar or wind or even the hydropower, if we'll consider, they all cannot completely replace energy resources. The reason is that due to the limitations, like suppose we want to have a solar plant somewhere in Rajasthan, like if you take the example of Rajasthan, recently some developments are there for the solar plant. But the thing is that for solar plant, solar energy is required. And 24/7 solar energy is somewhat difficult to get. Same thing goes with the wind also. And in the case of hydropower generation, we cannot generate hydropower electricity everywhere in the India. Maybe if you talk about the Himalayan region, we can generate that we can store, or we can create a reservoir. So, so the thing is that if we want to become a self-reliant, then switch from the coal, petroleum to some other resources. If we'll talk specifically about India, solar, wind, and hydropower are one aspect. Then we have the nuclear energy, and apart from recent developments are there in the field of geothermal energy also. And apart from that, we have the oil and gas shales. If we'll talk about the complete Indian basins, different basins. If we'll talk about the Krishna Godavari basin, it's a rich source of shale gas. Same way in some locations, like if we'll talk about the Assam, sources are also taking over for the energy generation and all. So in my coming slides, I'm going to discuss about how we are going to generate the extract the or extract this petroleum or oil from the shale or gas from the shale, and then how we can utilize all these sources to convert these resources into something sustainable, or you can say the more climate friendly and all those scenarios. How we can convert all those things. One more thing is that, like, if we're continuously using the coal and petroleum, time they are going to finish. To switch to the different energy resources. It's going to be the combination of different resources. It's not like only solar. So geothermal, small delta towards the, and after so we are going those abundant power to generate the geothermal about it. And this scenario, like unconventional oil or conventional oil, conventional reservoir rocks, unconventional reservoir rock.
I think there is some technical issues. Let us wait to join him again.